Okay, question 3. So I'm gonna share my computer here so I can bring up my calculator so that we can plug in our L1 data, our L2 data, and then go through and determine if it's positive or negative or there's no linear correlation. Calculate the correlation coefficient. Now I give you the equation already, and we're going to use that to do our predictions and then to do our residuals. So let me go ahead and bring up my calculator here. Okay, so there we go. All right, so let me plug it in, stat edit. I've got some old data in here, so I need to clear it out real quick. All right, so I'm plugging in my L1, which is my observed values. So, which is right here. So 40, 60, 80, 100, 120, 150, and 230. And I'm gonna plug in my L2, 2.5, 3, 3.5, 4, 5, 6, and 8. Make sure you get your data plugged in correctly. I'm going to check mine real quick. It's easy to make a mistake. That all looks good. Now, the first question says, determine what the scatter plot's doing. So to do the scatter plot, I hit second, y equals. Make sure plot 1 is on. To turn it on, hit enter twice. Off should go from being dark to now being white like this. Hit graph. Now your graph looks more like this. To get it to change around to show the data, zoom, we always hit option 9, zoom stat. It reconfigures your window, and there you go. I can see a pretty nice linear graph, a positive correlation. So for part A, I'm going to say it's positive. Part B wants me to calculate the correlation coefficient. So let's do that before I go back to my notes. Second, 0 to turn on the correlation coefficient. Go down to diagnostic on. Okay, hit enter twice. Make sure you hit it twice. Now it shows it's done. Stat, right arrow to calculate, option 4. Enter, 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 enter. And there's my correlation coefficient, 0.996. It says the nearest thousandth, which is 3 decimal places, 0.996. Now, I already gave you the y equals mx plus b, the linear regression line, and this matches up to what is written right here. So let me go back to my screen here. And we had said that it appears to be a positive correlation, and 0.996 is our correlation coefficient. I gave you the equation in order for us to do the predictions. Now, to do these other 2 predictions, we are going to use our regression equation, and we plug in that appropriate x, which in this case is 100, and then I go to my calculator and type in 0.03 times 100 plus 1.23. And that gives me 4.23 here. And for this one, I'm going to use the x of 150. Okay, that's what I'm using. And 0.03 times 100 plus 1.23. Sorry, not 100. I meant to say 150. So 0.03 times 150, 5.73. Okay. Now, the reason why you do the predictions is to calculate over here, which we call the residuals, which unfortunately my document is not showing. So I'm going to write it over here is my residual column. On your Edulastic account, you can see it a lot better. To calculate the residuals, it's always the observed y minus the predicted. Now, what do I mean by observed y? That is your L2. That is your observed y. Your L1 is what we call our observed x. And there is my predicted. So what we do then is, to get this going, to do that first one, they already had the residual filled out for you. You do the observed y minus the predicted, which they did for you, and they have 0.07 in that first blank. And then for the next one, they did 3 minus 3.03, and that's the first one you have to do. So 3 minus 0.03 gives me negative 0.3. And then I keep doing that. Here it's going to be 3.5 minus 3.63. They did that one for you. For this next one, we have to do, and you get negative 0.23. They did this one for you. They got 0.17. We had to do this one, so 6 minus 5.73. And 6 minus 5.73, you get 0.27. And then they did this last one for you. Oops, sorry, got out of order here. Observed y minus the predicted, and they completed that one for you, negative 0.13. Now this box is what you should fill out, which should be over here on this side, which we call the residual value. Now, on the residual plot, I will always give you the plotted residuals, which is right there. Now, you need to fill out the boxes then, which they're not showing my other box. That's no big deal. What we're doing here is looking to see if there is some type of pattern that's occurring. And I'm going to say that I don't really see much of a pattern, okay? I got some up and down. I'm going to say no pattern. So what does that mean then? It means we do no pattern means it is linear. So let me see here. This is box B. Sorry, I was looking for what we were saying there. So we're going to say yes, the residual plot indicates the linear model may be a good fit for the data because there is no pattern. Okay. Oops, sorry, I should say yes. All right. Okay, I'm gonna go ahead with number 4 then. On number 4, it's the same question. There are differences. On that one, I gave you the picture. Now my document does not have it for you, so I'm gonna show you the pattern that is on your screen. And on this one, what I'm gonna say then is same thing. I don't see a pattern. It's all scattered about. So I would say no. All right. Sorry, it's all scattered about, and all scattered about means yes, it's linear. So yes, it may be a good fit for the data because there is no pattern in the residual plot. Okay. So let me go back to my notes then. Okay. And we said yes, it may be because we have no pattern here. No pattern. Okay. 1 second. Oh, just curious. All right. Number 5, the points in the scatter plot, they are clearly negative, and they pretty much make a line. So whatever one is closest to -1, and heck, they are almost all exactly on a line. So that's what we're going to say, -1.0. All right, I'm going to pause it right there.